Okay, just gonna go through the entire question, APGP, the final question, the one that we were doing yesterday. So, to guide you through the whole story, there's this girl, Carol. She's swimming away from a shore towards the ocean. So basically, there's a shore, okay, like the sand. Then she's going this direction, and of course, the ocean is somewhere here. So what happens here is that basically first minute she covers like 80 meter. And then because of fatigue, right, every minute from there will be 1% less than the previous distance covered. So when I see this part here, I'll be like, okay, this is definitely a GP where the first term has to be 80. So, she swims for 80 meter for the first minute, then 1% less, which essentially means that this will be 0.99 multiplied by the 80. And of course, if you continue on, the next distance that's being covered is 0.99 bracket 80 square. 0.99 square bracket 80. So this is like the first minute. This is like the second minute, the distance she covered. This is like the third minute, the distance she covered. Okay. So at the same time, right, there's this annoying ocean waves that push her back. So her first minute of swimming, right, on top of adding this one is adding because she swims for 80 meters. But there's this wave, right, that pushes her back for 4 meters itself. So when you realize that that's the situation, your first minute, right, you swim 80, but you got pushed back by 4 meters, which essentially means, right, you only swim 76 meter, if you understand. Now, for the second minute, just to make it a bit clearer for you, right, you swim this distance during the second minute. But the second minute, right, she was pushed back by 4 minus away 0.05. In other words, right, the pushing back mechanism is an AP, and the pushback mechanism will be, okay, the first push you back by 4 meters. The next one, I push you back by 4 minus 0.05 meters. So 3.95 meter is the next pushback. The next one, I push you back by 4 minus 2 bracket 0.05 meters itself. So what you see here is basically the pushing back mechanism, the AP. And you notice how I form is I won't write things like 4 and 3.95 and 3.9. I write it in the form of AP, A plus N minus 1 times D. I mean, try to create like the distance, common difference, and of course the pattern. So it's easier for you to see for the first 3 minutes what happens here. So the question isn't asking for the first 3 minutes. It's asking for the first 5 minutes. So if you really, really, really cannot see the pattern, it doesn't matter because all you need to do is to really go and write out, right, the first 5 minutes of total distance and of course the total pushback. You know what I mean? That means you start from here. This is the first minute of swimming, second minute, third minute of swimming, right? Don't you think that if you continue on, the next one will be 0.99 to the power of 3 of 80? This is the fourth minute. Fourth minute. And finally, the last one, 0.99 to the power of 4 bracket 80. That is the fifth minute. So if you just look at the purple part here, right? From the first minute all the way to the fifth minute, you add all of them together. That will be the total distance that she swam for the first 5 minutes. But you don't forget that there's also the part where she got pushed back. So if you go down to the part where the red part where there's pushback, right? The fourth minute, the pushback will be 4 minus 3, 0.05. And of course, the last one will be 4 minus 4, bracket 0.05 itself. So people, what exactly is the total distance traveled for this period? It's basically just add all the purple things together, minus away everything added up from the AP, which is the total pushback. That will be the distance between Carol and the shore for the first 5 minutes already. Okay, so simple as that, and you get the distance. Okay, then the next part, right, continues on to now given that the ocean waves become weaker, right, from the moment, right, she's far away, until, right, instead of 4 meters of pushing back, at first I'm pushing you back by 4, right? Now I'm only pushing you back at 2 meters per minute from the nth minutes onwards. Okay, meaning to say, right, from nth minutes, right, the number instead of 4, right, drop down all the way to 2. And then it stays consistently at 2. In other words, the nth minutes onwards, right, it will be 2 meter. N plus 1 minute, 2 meter. N plus 2 minutes, 2 meter. Understand? So there's no more 0.05 meter less than the previous minute. No such thing already. It's just from nth minutes onwards, right? From the 41st minutes onwards, right? everything is just -2, -2, -2, -2. That is the wording of the question. So we'd be like, okay, fine. There's no more AP from the nth minutes onwards, but I need to know what exactly is the nth minutes, because at first I start with 4 ma. Okay, I start with 4. And then after that, I got pushed back by 3.95 because 4 minus blah, 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 right? So what exactly is the n, right? Until I got pushed back by only 2. Very simple. This 2 minutes you're staring at, right? You just gotta ask yourself, is it an SN thing or is it like a UN thing where, at the nth minute, the distance pushback is just 2 meters? So if you think about it, it has to be a UN thing. So meaning you say UN, right? You just let it be equals to 2 because you want to find from the nth term onwards, right? The UN value, the term of the AP ends up at the 2. So the UN formula is A plus N minus 1 bracket times D, right? So in this case, the 2 is equals to A, which is 4, plus N minus 1 multiplied by the distance, common difference, which is negative 0.05, which will then give you the final answer that you need. You realize that your N will be equals to 41. Meaning to say, 41st minute, including 41 minutes, right, is already 2 meter pushback, -2. 41st minute, -2. 42nd minute, -2. 43rd minute, -2. Okay? So after you realize that already, right, you have a situation, because your GP, right, is consistently continuing all the way beyond the 40th minute, right? 41st, 42nd, you're still using the GP. But your AP is broken down into 2 parts already, people. Your AP, right, is broken down into a part where there's the first 40 minutes. Like first 40 minutes itself, right? What's going to happen? Your GP is still consistent. The 41st minutes, right, onwards, like that, onwards, right? You realize that your GP is still the adding. You're still swimming outwards. But then your minus part, which is the AP, right, is no longer like that anymore. So it's no longer AP already. It will just become -2 from that. So what does this tell you? This tells you that there's actually two different patterns that's ongoing. So if you can understand this logic, right, the next question, part 3, which is the 5 marks, they say, hence, can you find the time taken for the distance between Carol and the shore? Add up all together. You know how we found the first 5 minutes distance, right? Part 1, how do we find the first 5 minutes? We add the GP together, we minus away the entire AP. Now, then this one say, hey, you gotta find the total distance to be at least 5,000 meters, 5 kilometers, you change to 5,000 meters. So I'll be like, okay, I should do that, but I must understand that the first 40 minutes and the next 41st onwards minutes is different equation. So for the first 40 minutes, right, we gotta let n be equals to 40, you let n be 40, and then you go and calculate what is the distance for like the first pattern. When n is 40, right, your GP, which is the SN, right, the formula will be A bracket 1 minus R to the power of 40 divided by 1 minus the R. And the GP I'm talking about is like the purple, the purple GP that you see there. Okay, 80 bracket, blah, blah, blah. Then you need to minus away, right, the sum for the SN term, right, for the AP, which is basically the pushback. The pushback, you must minus there also. Then you can get the total distance traveled for the first 40 minutes. So that will be the AP. And the AP formula will be, of course, N over 2 bracket 2A plus N minus 1, 40 minus 1, times difference itself. So 40 minus 1 times the common difference. Do you have the first term of the AP? And do you also have the first term of the common difference of the AP? You have. So if you take the formula you see on the right-hand side, right, you minus off, you will realize that you end up with this distance, 2527.2 meters itself. Meaning to say for the first 40 minutes, you would cover 2527.2 meters. But the question asks you for at least 5,000 km. So what do we need to do from here? We need to basically be like, okay, I need to cover 5,000 km, right? I must minus away 2527.2 first, because I want to find out, right, for the 41st minutes onwards, right, how much am I supposed to travel, So if I take 5,000 minus away 2527, right, I will get something like 2472.8 meters. So this 2472.8 meters is the entire from 41st minutes onwards. You find the total distance, swim and gonna push back by 2 meters per minute. That one equals to 2472.8. You can then find the N for this shaded part here, meaning to say I'm trying to find the n, right, starting for this 2472. So what do we do here? We be like, okay, the 41st minute means to say the sum of the GP term, right? This sum of the GP term must start from the formula A. And you know what is the A or not? The A, right, is the first term of the 41st GP. That means to say the SN, right, the UN, right, for the 40th term, which is like that, UN for the 40th term, right, is A bracket R to the power of n minus 1. So let me just write out the GP formula first. UN is A R to the power of n minus 1, correct? So if you're going to find the first term, which is the 41st term, right, U41, right, it will be A. A as in legit the GP, right? Original, this one, the GP, the A. So if you start at 80 itself, the first term would have to be 80, then multiply by 0.99 to the power of 41 minus 40. Once again, why are you doing this? Because you want the first term of the new GP to find the SN. So the first term, if you were to press out a calculator for this thingy itself, right? Okay, you get whatever lah. Okay, this thing here would have to be a first term. Okay, so when we press 80 multiplied by 0.99 to the power of 41 minus 40 minus 1, you basically get this, which is 53.5177 meters itself. Okay, so from 41st minute onwards, right, my first term is actually this one. So the first term of the new GP is 53.5177. Now, what is the common ratio? The common ratio has to be the same. So the common ratio for this one, right, will turn out to be 0.99 as well, because you still get tired, then you still minus 0.01%. I mean 1% every single minute. So still the same for the common ratio. And then on top of that, the n is the unknown. So n is the question mark that you are trying to find. Okay, n is the question mark. Number of minutes starting from the 41st minute. How many minutes does that count? This one will form an equation in terms of like the sum of GP. Then you must remember this thing, right, must minus away. You see the 2 there or not? The 2 is no longer AP already. You must push back by 2 meter every minute. So that sum, right, you must minus away 2 times of the n, which is 2n. That would then be greater or equals to this number, 2472. So basically what I'm explaining is, I just want you to know that from 41st minute, right, she's swimming out with a new GP term. The first term is different, the common ratio is the same, and you want to find the n, right? You must minus away 2n, because it's like you push back by 2 meters every minute. So 2n will be like that. So if you take that minus that, right, the GP minus the AP, right, the GP minus the constant series, you must let it be more than or equals to the remaining distance, 2472.8 itself. From here, GC out, you will solve and you will get an answer for n. You realize that your answer for n, right, is equals to 67 itself. So n is 67 is not the final answer. The question asks you how much time is required, right, for her to actually get to be at least. So find the time taken. The time taken, right, is basically total out of the first 40 seconds, okay, plus the 67 seconds that you found for the unknown t. The unknown of the second part n. That will give you 107, which is the final answer for the time taken total. Okay, then that's for part 3. So basically, after we solve all this already, right, for part 4 itself, what we got to do is we got to actually find the greatest distance, right, between Carol and the shore. And you know, right, for me to actually find the greatest distance between Carol and the shore, we have to go back to this equation, which is this one, like here. And we have to let it be type out the whole equation into the GC. Remember, because you always need to use the GC table method to discover the n, the largest n. So we use this one, like the Sn of the GP, right, minus away 2n itself. Okay, then we continue scrolling down, because I believe what you did here was you also GC table, right? Then you scroll down until you can see 67 being the number that is more than or equals to 2472.8. But now you don't stop at 67. You reach some number that's more than 2472.8, you don't care. You continue to scroll down itself. So if you continue to scroll down, right, you could find the number, right, as far as it can go. You know what I mean? Like you gotta find the largest possible number, right, that you can push to. Just keep scrolling down the GC. don't stop at the part where it's 67, which is basically 2472.8, right? Bigger than that. No, you just keep going down. You keep going down and push and see what's the highest number that you can reach. So if you keep pushing down, right, you will realize that there is a very interesting moment because you'll reach a point where you have a number, and then the next number that comes out, right, would have to be something that's smaller than the number. Very interesting one. So I'll just tell you, based on the answer itself, right, if you continue to scroll down and scroll down and scroll down, right, the number that is going to become the case, right, is t is actually equals to 328. When you reach the end, okay, the end of the t is equals to 328 itself, right, you realize that the total distance traveled is 4497.7196 itself. Okay, that means when t is equals to 328, you realize this will be from the 41st minute onwards, 328, right? Your distance covered will be the max. If you proceed on to 329, okay, you know what can happen? If you proceed on to 329, right, you realize that the number will drop down already. It will, based on the GC, right, drop down to become 4497.7004, which means the highest number, right, is occurring at this one. And what would be the time? The time for her to reach the maximum distance away from the shore is actually 328 plus the first 40 minutes, which is 368 minutes. And the total distance for that to take place is 4497.7196, right? Plus the first 2527.2, because that will be the original first 40 minutes distance. So the furthest she can actually go, right, okay, away from the shore is 7,020 meters, which means 7.02 km away from the shore. Okay, so why do you think, right, from there onwards, people, why do you think that the distance dropped? Like the total distance away from the shore became like less and less and less and less and less. Do you know why? Because the shore is pushing her back the waves are pushing her back at 2. So, she becomes tired, and then after that, the ratio is 0.99, so it continues to go down and down. So eventually, the 0.99, I mean the plus GP, right, will be less than the 2, because consistently every pushback is 2, so she cannot push back more than she's swimming out because of fatigue. Therefore, the waves will push until she cannot push to the shore. Yeah, so imagine you drown, then you just cannot push back, wash up the shore like some dead whale or what, something like that. So that will basically explain the entire question 4, which is quite disgusting, this question. Okay, so hope you understand this.